Okay, so let's think about tossing up a ball. So let's say I toss up the ball and here's point A, and we'll say this is when it just leaves the hand. Just leaves hand. Okay? Then let's just pick, let's do a middle point and say that's point B. That's like midway or halfway. And then let's do the last one is C, is max height or maximum height. Okay, so here let's do position A on this graph. So this graph will represent position A. So hi. Sure. Yeah. That's fine. Yeah. Okay, so say I toss the ball up, okay? When, and let's just think about it going up, not coming down. What is it, where is it moving fastest when I toss it up? Which point do you think is it moving fastest? When it just leaves my hand. Yeah, it's going the fastest when it just leaves my hand. So let's say all of EM goes up to 10. Let's just say that for this question goes up to 10 joules. So what should my EK be for just leaving my hand? Probably just 10, right? And I won't have any EP because it's just leaving my hand. And my reference point is like my hand is 0, right? So you have that reference point, this is like my hand is 0. It does have a gravitational potential energy reference to the ground, but reference to my hand, it's just 0. So now let's do, say, position B right here. So all of EM needs to equal 10, because that stays the same. According to law of conservation of energy, EM has to equal 10. But what should my EK be about? What would you guess? Say it again? Half, yeah. I would say it's about half. So 4.5 is my EK, and that EK energy has been transferred into that EP energy, so now EP should also be about 4.5. And that's just approximate, okay? So now let's do position C up there. EM, again, is always 10. Now at that maximum height, does the ball have movement at that max height? No. We know our V is equal to 0, so EK must be 0 then as well. So I just leave, that's just 0. And my EP is 10. Okay, so that's like tossing a ball up. Let's do a pendulum now, since we'll be doing that in our lab. So let's just draw a little pendulum. Let's say it's swinging out, and its path is the dotted line. So it's going to be swinging. Now, the thing is with a pendulum, regardless of the height, we just set, when it's just hanging down, actually, could you hand me one there? It's easier. So, even though this is like off of the ground or even off of the table, we're going to reference this spot where it's just hanging flat as 0, okay? So even though it's off the ground, this is our reference point, so this is we're going to say it's 0. So anyways, I'll just keep going here. So when it's swinging up and down, at this point, this will be max EP, because that's when it's the highest from the reference point, okay? So max EP. And at that point, it will be min EK. Because it's going to kind of like stop there and come back down, right? So it's going to be slowest when it's at its highest. And then here at the bottom is going to be our min EP and our max EK. Okay, now since this is our reference point is 0, min EP will actually be 0. Okay, and min EK here will actually be 0. Because we assume that we're measuring it right when it actually stops moving and turns around and goes the other way. Right? When you walk and you have to turn around and go the other way, you actually stop momentarily. Right? That turn around. Is this making sense, or am I going too slow? Too slow? No? Okay. You're kind of blanking out on me, so I don't know if it's too slow, or I don't make sense, or you're just tired. I don't know. Okay. All right. So let's say this is position A, and this is position B. So position A. So again, let's just set EM to 10 again. EK will be 0, and EP will be 10. And then here, say we do position B. EM again needs to be 10 for conservation. EK will be 10. And EP will be 0.